So today's question for discussion is how do you select the HPLC column during method development? Obviously, this question will be asked to the people who wanted to have a job into the analytical research labs. Now, this question can be just beginning of uh, many more questions related to the method development. So, what is the expectation of the interviewer if you look at this question? Now, this is very broad questions and there can be multiple possible answers to this question. But how you can construct the answer so that the interviewer will see you as a someone has a deeper understanding about the HPLC column chromatography and you expect to talk about the stationary phase and the possible interaction of the stationary phase with your molecule. So if you can bring this information as a part of this answer, you can build the credibility and certainly going to influence the interviewer. So if you look at the as the HPLC method development, almost 90% of the methods are developed by using reverse phase chromatography. So I advise you to talk about the reverse phase chromatography much rather than speaking about the normal phase chromatography. If it is at all required as a part of your job description, then you can talk about normal phase. Otherwise, reverse phase is going to serve the purpose. So, where you are going to begin? So, when you talk about the column chromatography, the stationary phases for the reverse phase chromatography, you know the most prominent interaction is the hydrophobic interaction. Most prominent interaction is the hydrophobic interaction. And who brings the hydrophobic interaction? It's the hydrophobic stationary phase. And what are the example of hydrophobic stationary phase? We can talk about C18 or C8, which are highly commonly used hydrophobic stationary phases. So you can start your answer with, in case if my molecules are hydrophobic, if my molecules are non-polar, then I will start with the hydrophobic or non-polar stationary phase like C8 or C18. So you are not only talking about the stationary phase, but you are also talking about the possible interaction with the molecule and why you want to select this particular stationary phase. Because your molecule is hydrophobic non-polar in the nature, and you can see that the non-polar interaction is going to be a possible mechanism of the retention for this molecule, and hence I am going to select C8 or C18. But in case if my molecule are having functional groups, my molecule contain electronegative atoms, my molecule is a polar molecule, then there can be a many more options available. Now, what is the drawback of reverse phase chromatography? Your polar molecules will not retain for the longer time onto the stationary phase like C8 or C18, which is hydrophobic in the nature. Now, to retain these polar molecules for longer time, you need to bring the polar stationary phases. So, how you can begin the discussion? In case if my molecule contains a functional groups, for example, a carbonyl functional group, which contains C double bond O, I'm very much sure that I can take the advantage of C double bond O carbonyl group because oxygen is highly electronegative atom, right? And this oxygen is going to pull electron cloud towards itself. And out of that, this oxygen is going to develop a slightly minus delta charge. Oxygen will have a slight minus delta charge. And that is going to make this carbon with a slight plus delta charge. The carbon will have a slightly plus delta charge. So there is a formation of dipole. There is a formation of a dipole. In case if you want to retain this molecule for longer time, which is having a dipole now, your stationary phase must also have a dipole, that is plus delta and minus delta. And then the dipole interaction will come into a play. Now, what are the stationary phases which have a dipole? What about cyano? Cyano stationary phase predominantly is having C triple bond N. Now, this C triple bond N, as you are seeing over here, this nitrogen is going to have a minus delta charge. Why? Because nitrogen is highly electronegative atom, and because of its highly electronegativity, nitrogen is going to attract electron cloud towards itself and making it negative and leaving a plus delta charge onto the carbon. So can you see that this minus delta charge onto the nitrogen, right? Minus delta charge onto this nitrogen can get attracted towards the plus delta charge present onto the carbonyl carbon. Similarly, this minus delta charge onto the oxygen can get attracted towards the plus delta charge onto the nitrile carbon, this carbon. And there forms a force of attraction between the carbonyl functional groups present onto your molecule and the cyanofunctional groups present into a stationary phase. And that is the reason you are going to select polar stationary phase like cyano. Does it make sense? Now this is not just the point, right? You can also explain which the amino stationary phase or amide stationary phase in the same way, because they also form the dipole, and then dipole-dipole interaction comes into a play. If you want to explain about the pi-pi interaction, in case if your compound, if your molecule contains phenyl ring, your molecule contains phenyl ring, then obviously this phenyl ring of your molecule can form the or can get retained onto the phenyl column with the pi-pi interaction. Now how this interaction is going to happen? There are pi electrons present inside your phenyl ring, which is your molecule or analyte. And obviously on the phenyl column, you will have the phenyl rings, which also contains the pi electrons. So the pi electrons of the molecule and pi electrons of the column will get interacted, which is called as a pi-pi interaction. And this is how your compound will get retained for the longer time. Now the phenyl column also brings the hydrogen bonding interaction. So in case if your compound has the hydrogen atom attached to highly electronegative atom, for example, there is a alcohol group present into your compound. Now this hydrogen present into your molecule will have the plus delta charge. The reason is very simple. This oxygen is highly electronegative. It will attract electron cloud towards itself and become minus delta and leave the hydrogen with plus delta charge. So this plus delta on the hydrogen can have the interaction with the pi electrons present onto your phenyl column. So this is the benefit of using the pi. This is the benefit of using phenyl column. You can bring the pi interaction or hydrogen bond interaction, because of which a polar molecule can retain for the longer time. In case if a molecule is highly polar and it is not at all getting retained even onto the phenyl column, and you need a stationary phase which is highly polar in the nature, and that's where the pentafluorophenyl stationary phase comes into a play. Now this pentafluorophenyl stationary phase contains 5 fluorine atoms present onto the phenyl ring. So this 5 hydrogen atom of the phenyl ring will get replaced by, sorry, so the 5 hydrogen atoms present onto the phenyl ring will get replaced by the fluorine atoms. Now what is the property of the fluorine? Fluorine is highly electronegative atom. And if it is highly electronegative atom, it is going to have the very positive attraction towards the polar atoms where there is availability of dipole. For example, in this case of the alcohol. Now this alcohol, this oxygen is with minus delta, right? So let me draw a charge on the oxygen. Oxygen is with minus delta and your hydrogen is with plus delta. So the fluorine atom present onto your molecule, your column, the fluorine atom is going to have a minus delta charge. It's going to have a minus delta charge. And this fluorine with minus delta charge, if I have to draw a simple bond of the fluorine, right? Of course, there is a phenyl ring. I have just taken the carbon to demonstrate this minus delta charge and the plus delta charge, that you can understand what I am speaking all about. And this carbon will develop a slightly plus delta charge. So this is going to be a situation now. So this minus delta charge of the fluorine can get attracted towards this plus delta charge present onto the hydrogen, right? It can form the hydrogen bond also. And in case if there is another molecule, another atom in place of hydrogen with a plus charge, this minus delta charge will have the attraction towards the plus delta charge onto the molecule. Now, because of this force of attraction, your polar molecule is going to get retained onto the pentafluorophenyl stationary phase for good amount of time. In addition to the in addition to dipole-dipole interaction, the way I discussed, explained it right now, there is also the possibility of the pi-pi interaction into the pentafluorophenyl stationary phase. See, the pentafluorophenyl, it contains the phenyl, right? It basically a phenyl ring containing the pi electrons. So as like phenyl column, pentafluorophenyl column also have the additional mechanism of interaction, that is the pi-pi interaction. So the pentafluorophenyl can interact with the molecule with the mean of, let us say, pi-pi interaction. Okay, so let me make it in the normal text. I'm just trying to make you clear what are the possible interaction in case of the pentafluoro. So pi-pi interaction, you understand. You also understand the dipole interaction, and there is also the hydrogen bond interaction possible because of the pentafluorophenyl. So for highly polar molecules, or the molecule having the possibility of the hydrogen bond formation, the pentafluorophenyl is a very suitable stationary phase. Now, I think we talked about hydrophobic interaction, we talked about the hydrophilic interaction, and with the suitable number of examples, how the interaction is going to happen. It is also important to talk about the column dimensions. So far, we talked about the chemistry part of the stationary phase. You need to also talk about the column dimension part, because the dimension of column also has a significant role in your resolution or the retention mechanism. When you talk about the, okay, so before we go on to the dimension part, what I would like to discuss is the another physical properties of the column. Physical properties of the column. What is meant by physical properties? It can be about, let us say, carbon load. We can talk about the specific surface area. You can talk about um, the pore size. Now, I recommend that you must not forget to mention at least these three important properties: the carbon load, the specific surface area, and the pore size. These are very important properties of this silica particles. So, what is the relation of the carbon load with the retention? It's very simple, right? The higher is the carbon load, the higher will be the retention time. Similarly, the specific surface area also has a very important role, and that role is what? Higher is the specific surface area, higher will be the space available for the interaction. And if there is a more space available for the interaction, certainly the analyte is going to retain for the longer time. So the retention will be more with the more surface area. The pore size. The pore size talks about the more the are the number of pores available onto the silica particle. Obviously, you are going to have the bigger specific surface area. So smaller is the pore size, the more will be the surface area. Higher will be the bigger is the pore size, the smaller can be the surface area. And you can relate then what is going to happen onto the retention of the compound. The another important point can be a particle size even, and or we'll talk about the particle size in dimension. So we talked about the physical properties of the column, and let us talk about the now what are the importance of dimension, the column dimension into the separation. See, there are length, diameter, and particle size. Now, these are the three important parameters that you need to discuss as a part of the dimension of the column. So, the increase in the length is going to increase in the retention time. The diameter is very important parameter. The diameter, the shorter is the diameter, the better will be the efficiency, better will be the resolution, the sharper will be the peak. The peak height will get increased because of the shorter diameter. And nowadays there are columns available with around 2.1 mm inner diameter. So in case if you are stuck at the critical separation, you can think of these HPLC columns with a reduced diameter. Particle size also has a similar impact. So lower is the particle size, the better will be the resolution and efficiency and number of plate counts. So I think with these three important dimensional parameters, you can able to understand, you can able to make the interviewer clear which column I need to select will depend on to the number of compounds to be analyzed or the complexity of separation. And once you complete this discussion, uh, your chemistry part, your physical properties, column dimensions. Don't forget to give a case study. It's very important. You must talk about a case study during this particular interview question. So prepare for one case study in which you have tried out different columns and then you have selected a column. Give the logic why that particular column was selected. You can also talk about the column end capping, the base deactivation of the column, because most of the times for the basic molecules, right, the peak tailing will be just high because of the secondary selenol interaction. In case if a molecule is basic, obviously you are going to select the base deactivated or end capped columns. It's a very important point. The another important point I missed is about the pH range of the analytical columns. So generally 2 to 8 is the pH range, but in case if you want to operate the column for the higher pH, then there are some columns available like YMC triad or the waters extera. So these stationary phases are also available in the market. Talk about some brand names, some columns, so that the interviewer can relate with you in the sense of you have already done the HPLC method development. Talk about the case study for sure. It's a very important point. So I hope this particular small presentation would have given you a better understanding on how to respond to the question of HPLC column selection. Thank you so much.